Hey folks! Today's dive into steam boiler water treatment, and the ZESTOS system might sound basic, but the engineering is mind-blowing. Quick question. Does Blowdown really supercharge a boiler's lifespan?
Oh yeah, it boosts equipment longevity and steam quality big time. Where we drop blowdown tips that'll extend your boiler's life for free, just smarter maintenance vibes.
Love a free upgrade. Let's get into it.
Alright, first up, the unseen villains hiding in your feed water: dissolved oxygen and carbon dioxide.
Wait, dissolved gases? Like in a soda?
Exactly, but in a boiler, if you leave them unchecked, they trigger pitting corrosion. It's this incredibly aggressive, localized rusting that literally punches deep holes straight into the metal.
So it just eats right through the pressure vessel walls?
Yep, which is absolute nightmare fuel for any high-pressure steam setup. Chemical Conundrum.
So what's the traditional fix? Just dump a bunch of chemicals into the tank?
Pretty much. You pump in oxygen scavengers like sulfites to bind with the O2 and buffers to keep the pH cranked between 8.5 and 11 to neutralize acids. It mostly works, but some oxygen always sneaks by.
Why is this the standard for low-pressure boilers then?
It's cheap to set up. You just need a dosing pump. But here's the engineering catch. Think about what happens when the water boils. Do those chemicals turn into steam?
No, they'd get left behind in the liquid water.
Spot on. As the water boils off, your total dissolved solids, or TDS, skyrocket. That messes with the water's density and surface tension, opening up a whole new can of worms.
Looking at the engineering notes here, this brings us to water carryover.
Yes, which is exactly what it sounds like. Liquid water droplets hitching a ride into the steam lines.
Because of the surface tension change?
Exactly. High TDS lowers the surface tension, turning your boiling water into a violently foaming mess. Imagine putting dish soap in a washing machine.
So instead of a clean boil, it's just a wall of bubbles?
Wildly bubbling, and as those bubbles burst at the surface, they fling chemical-laced water droplets straight up into the steam pipe.
That sounds terrible for anything downstream. Don't industrial presses and turbines need perfectly dry steam?
They demand it. When carryover hits, efficiency plummets. Laundry takes longer to dry, irons spit out dirty water, cooking processes get ruined. The very chemicals meant to protect the boiler end up wrecking the process.
Classic case of the cure being worse than the disease. So, enter the ZESTOS system. Instead of fighting chemistry with more chemistry, it uses physics.
Total game changer. It leverages pure thermodynamics.
Right. It captures the latent heat from waste steam, stuff that normally just gets vented out of steam traps, and routes it into a patented recovery tank.
Exactly. It uses that waste heat to preheat the feed water and condensate to just below the boiling point. And based on basic physics, what happens to gas solubility as liquid temperature rises?
The gases get kicked out?
Bingo. ZESTOS scales this up beautifully. It aggressively heats the water, driving out the dissolved O2 and CO2.
And then just vents them to the atmosphere?
Yep. By the time that water hits the actual boiler, the dissolved gas levels are essentially at zero.
So if the gases are gone before the boiler, you can cut back on the chemical dosing.
By up to 90%. It's a massive operational saving. Your TDS levels stay super low, which completely eliminates that foaming issue.
Meaning a much purer boil yielding hotter, higher quality steam.
It's thermodynamic bliss. You get less thermal shock on the boiler, lower metal fatigue, faster steam generation, and noticeable fuel savings.
There's gotta be a catch. ZESTOS isn't magic.
The catch is the upfront capex. It's a physical hardware installation, not just a bucket of chemicals.
Worth the ROI?
Usually, yes. It pays for itself by massively extending the boiler's lifespan. But to be clear, it's not 100% chemical-free.
So it's a hybrid approach?
Exactly. ZESTOS does the heavy lifting, the degassing, and preheating, while a tiny fraction of the usual chemicals handles the final 10% of water conditioning. Brilliant synergy.
Okay, let's pivot to those blowdown rules you promised.
For low-pressure boilers, The standard is maintaining TDS between 2,000 and 3,500 parts per million by dumping about 4 to 8% of the feed water, which is super easy to manage with cheap TDS meters. You just test the water and tweak your blowdown valves.
You can do a continuous surface skim, but I want to talk about bottom blowdown. Blasting high-pressure sludge out of the bottom of the tank?
The piping down there takes a brutal beating. You're forcing boiling, abrasive sludge through relatively small pipes at insane pressure.
Is that why code mandates 2 valves in series?
Yep. You have a primary quick opening valve closest to the boiler, and a secondary slow opening valve right behind it.
Why not just use one incredibly beefy valve?
Think about it. If you used just one valve close to the boiler, and you barely cracked it open to throttle the water flow, what do you think would happen?
You'd have a massive pressure drop across a tiny gap. That high-temp sludge would blast through at supersonic speeds.
Exactly. And that high-velocity sludge acts like a sandblaster. It completely shreds the valve's internal seating. In mechanical engineering, we call this erosion wire drawing.
Oh man. So if that single primary valve, which is basically the boiler's lifeline, gets eroded and can't seal anymore, you've got an uncontrollable, high-pressure leak continuously draining your boiler. That's a nightmare.
It really is. Quick side note. Tiny boilers under 100 pounds per square inches actually do only use one valve. For those, you have to constantly check for leaks and swap the valve preventatively. But on the big 2-valve setups, protecting the system comes down to a strict, scientific operating sequence. It's all in the order of operations.
All right. Spill the sequence.
First, you open the primary valve fully and fast. Because the secondary valve is completely shut, there's no water flowing yet. No flow means zero erosion.
Got it. The primary valve is safe.
Then you slowly open the secondary valve. It takes the brunt of the high-velocity throttling.
So the secondary valve is basically the sacrificial hero taking the punches?
Precisely. It's built for it. When you're done, you reverse it. Slow shut the secondary valve first to completely stop the flow. Then snap the primary valve closed safely.
I noticed the manual says to briefly reopen that slow valve after you close everything.
That is a great pro move. When you trap super hot sludge in the pipe between those 2 closed valves, it starts to cool down and shrink. That creates a powerful vacuum that can actually suck in and damage the valve packing.
Ah, so cracking it open just relieves that vacuum and equalizes the pressure.
Exactly. Battle-tested wisdom right there. Now, regarding the actual blowdown process, fluid dynamics dictates that it's way more effective to do multiple short, powerful bursts like 5 to 10 seconds each, instead of just opening the valve for one long stretch once a day.
That actually makes perfect sense. If you leave it open too long, you lose the sweeping effect. Instead of pulling sludge from the wider floor of the tank, it just forms a vortex and pulls down the relatively clean water from directly above the drain. I think that's called rat-holing. The heavy sludge you actually want to remove just sits there undisturbed on the floor.
You've got a sharp grasp of fluid dynamics. Short bursts sweep a much wider area. Plus, if you dump too much water at once, the boiler has to instantly gulp down a massive amount of cold, fresh feed water. That increases the chance of introducing a huge spike of oxygen, which shortens the boiler's lifespan.
Which brings us right back to the beginning. Oxygen kills boilers.
Full circle. Short, frequent blowdowns are drastically safer. And one golden rule: if your blowdown piping springs a leak, fix it immediately. Ignoring it can lead to catastrophic accidents.
Mind-bending info. Anything else?
Don't skip water softeners. Check our last vid.
More engineering gems next time. Thanks for watching.